Well, thanks everyone for attending my talk. This talk is on macOS Tahoe's ClickFix paste protections. I'm Ferdous. I go by MalwareZoo on X. This is my first Mac DevOps and my first time speaking here. So I'm really excited to share this research with you all. So a little bit about me. I'm a security researcher at Jamf Threat Labs, based out of Toronto. We spend most of our time analyzing macOS malware and building detections for it. And some of my past work covering various malware is shown on the slide, plus some occasional vulnerability research I get to present at security conferences. So I got a lot to get through, and we'll start with ClickFix on macOS and how it works, what it is. Then the two paste protections Apple added in Tahoe. The first one is inside of Terminal, the Terminal application, and the other one is inside of XProtect D, which is the XProtect daemon, which scans content both when you paste and when you run commands. And there are a few demos as well. So we'll see if these protections are actually good enough to stop ClickFix attacks. So in Tahoe 26.4, people started getting these new paste prompts, and there was basically zero documentation on what they were doing at the time. So back in March, I looked into them and posted a couple threads on X, and had people reach out to me that were also curious about these new protections, and that's what really got me to sit down and analyze and reverse the 26.4 binaries related to this feature. So by a show of hands, how many of you have seen any of these prompts before? Okay, so several people. Um, so that's exactly what we'll be covering today, exactly how these prompts work behind the scenes, why they display, and the inner workings of it. So just recently this month, Apple actually updated their support documents with a little bit more information about some of these prompts. So they say for the terminal prompt that it's possible malware. An alert shows up if you don't normally use terminal and you copy commands from a website, chat agent, or email. And the other two show up when macOS thinks a command or script contains known malware. But it's still pretty vague on some of those what conditions these prompts will show up. So we'll be taking a look into that. So let's talk about ClickFix and what ClickFix actually is. So ClickFix is a social engineering technique that it's not really macOS specific, but it's a fake website, tells you to open terminal and paste a command, and that command goes to download and install malware. And usually it's delivered through a malicious website, fake software update. It could be a GitHub repo, sponsored ads. And the interesting part is that the user runs the payload themselves. It's almost always like a curl command that's piped to an interpreter. So it runs directly in memory. So a lot of the things that Calvin talked about in his talk, like gatekeeper, notarization, code signing, a lot of the things that are really important and are built into the operating system, none of that really kick in here because the command is directly curling and piping something to an interpreter. So that's the gap Apple's really trying to close here with these new ClickFix paste protections. So they're two separate systems. One lives inside of Terminal, but not everybody uses Terminal. So Apple gave themselves broader coverage with XProtect D, the XProtect daemon. They're completely different binaries, have different checks and different prompts. So let's start with the one inside of Terminal. Terminal runs a bunch of checks when you paste and when you paste content, and all of them have to pass for you to get that prompt. The thing to know is that Terminal never looks at what you pasted. This is all behavioral checks. So it's trying to catch that one specific scenario where a user isn't a developer, they don't really use Terminal, and they're only pasting something because a scam told them to. So let me go through each of these checks. So the first check is where the content came from. So the source app has to be one of 73 apps that Terminal watches for. That includes browsers, email clients, messaging apps. And if you copied anything outside of that list, you won't get that prompt. And by the way, if any of these checks fail, the paste will go through. So for those of you that are interested, there's the list of various browsers, email clients, messaging apps, and that also includes preview and text edits. So um, presumably these are the channels that attackers are using to target victims for ClickFix attacks. So the second check looks at the modification time of a hidden file under VARDB, Apple setup done, and that gets written by Setup Assistant when your setup of your Mac finishes. And if it's less than 24 hours old, the warning is suppressed. My guess is that that's to avoid annoying people on day one of a fresh machine. So to put it in plain terms, it's basically the system install date. If it's under 24 hours old, the warning gets suppressed completely. And you could check it with the stats command, and you can also backdate it with the sudo touch time stomping if you'd like to test this. What's a funny thing is that we actually observed North Korean threat actors also check the modification timestamp of the same file to see if they're running on a fresh system that could be a test machine or a VM. The third check is whether you're a developer. And it figures that out in two ways. One, it checks to see if the library developer folder exists, which gets created by Xcode or the command line tools. And it also it asks launch services about 33 different known developer app bundle IDs. If any of those exist on the system, it assumes you're a developer and it stays quiet. So that is the list of different developer app IDs, and then yeah, the folder there. So the last couple checks it does is it checks to see if terminal has been opened in the last 30 days. So if you're someone who barely uses terminal and you've never clicked paste anyway before in that prompt, if all of that line up, you finally get that prompt. So the last two checks are two keys in com.apple.terminal. The last terminal start time is the previous launch time of terminal, and that gets read at startup and then overwritten right away. And then the user acknowledged paste warning. If this is set to 0, if you clicked don't paste, or it's set to 1 if you clicked paste anyway. And if you click 1, that warning is suppressed completely because they don't want to bother anyone. If someone knows what they're doing and they're allowing the paste, then the warning is just completely suppressed for terminal. You could also just delete both of those with default's delete command if you want to test this yourself. So finally, once everything passes, you get that prompt. And notice how it says possible malware. It's not certain for sure. And the content was never looked at. This whole thing is about behavioral. If someone's launching terminal, someone that never uses terminal and is not a developer, Apple's pretty confident that they're likely doing something malicious. Here's a quick demo of that. And to show that the content doesn't really matter, I'll copy like hello world out of TextEdit. And TextEdit was one of those applications it monitors. And if I just paste it, you can see I allowed the paste to go through, but there we got that prompt. Now the second protection system is in XProtect D. This one's the complete opposite. It actually reads what you paste, which is pretty interesting. So how exactly does it do that? So XProtect D subscribes to a private endpoint security event called ES Event Paste T. It's an authorization event, so Apple can deny the paste. And then from there, it checks if the target is a terminal. If the source is a browser, and it also checks to see if there's any domains or IP addresses contained within the paste, and looks them up and checks them against the Safari Safe Browsing service. If a domain is flagged as malicious, the deny paste is set to true, and the command is just blocked. The paste is blocked. And like terminal, this is applied to everyone, developer or not. So let's look at the first check. It first checks to see if the target process is attached to a pseudo terminal. So instead of hard coding a list of terminal apps that can change, many people use different terminals. So it just checks to see if it's attached to a pseudo terminal. This is actually a nicer approach. So It works with terminal, iTerm2, Ghosty, VS Code's built-in terminal, anything that allocates a PTY master and a slave. So XProtect D covers any terminal emulator without having to maintain a list that it has to keep updating. Next is the source check. It resolves whoever. So sorry, there's a list of 24 browsing IDs, the code signing ID of the source process. So if the source process is not a browser, that check is skipped entirely. So here's a list of the different browsers it looks for. This is within the XProtect daemon, the checks it does. So if the terminal target and the source is a browser, it calls a function called parse IP address and URLs to pull any domains and IPs out of the text you paste. So a quick version of how it works. It calls NS data detector with the link type to get the pasted content, grab any URLs, and then dedupes them. And it also extracts any IPv4 and IPv6 from that command. I won't read that regex unless someone wants me to. So then each domain gets checked against Safari Safe Browsing Service. This is the same service that warns you about a fraudulent site that you visit within Safari. And if anything comes back flagged, the paste gets denied. So you could see with the OTool command, if you run OTool-L against the XProtect daemon, you could see that it's linked against the Safari Safe Browsing Framework. And then there's various different flags, whether it detects it as phishing, malware, it's known to be unsafe, or unwanted software. If any of these flags are set by Safari Safe Browsing Service for that domain or IP, the paste is blocked. And the nice thing is that everything lives server-side, so Apple doesn't really need to maintain like a list of like malicious domains on disk or something like that, or require an XProtect update. So if all those checks pass successfully, you finally get this other prompt. Malware detected, paste blocked, no option to override it. As long as you copied it from one of those browsers into a terminal and the content has a flag domain, it's blocked for everyone. So here's a quick demo. I'll open Safari. I'll grab a command with a known malicious domain in it and paste it into terminal. And as you can see, I get malware detected, paste blocked. And it doesn't really matter which terminal application you use, as long as there's sudo terminal. And here I visit another malicious site. You could see I get that red prompt in Safari. But in terms of like a ClickFix attack, you'll typically have a curl command with that domain contained within it that's piped to some interpreter. So these two components, so these two different systems complement each other. Terminal is the behavioral one. It catches the pattern where someone isn't a developer pasting from a browser who hasn't opened terminal in months, even if what they pasted is totally harmless. And XProtect D is the content one. It catches known malicious domains, even if you're a developer who lives inside of terminal. So you get the behavioral detection and the content detection together. The coverage is different too. Terminal watches like 73 different apps, emails, and messaging applications. XProtect D at the moment only has 24 different browsing identifiers, but that's typically where malicious URLs will come from. I suspect Apple will expand that list in future updates. So that's the first two prompts. There's also a third prompt, which is the one that you see here for malicious script blocked. And this one actually scans paste content at runtime. So you might be thinking, okay, so what happens when an attacker just like encodes their command that like makes you run an echo pipe to a base 64 decode and then pipe to another interpreter, or they completely encrypt their command in some way. Eventually that command needs to run. So what Apple is doing here is that they're monitoring the arguments at runtime for when that paste happens. So all those checks still need to pass. So if the attacker obfuscates the domain to get past the paste check, XProtect D can also look at the command arguments when it runs. So here I copy an obfuscated command, and paste it in. It doesn't really do anything. It's just ls and a domain. But here you'll see if I copy it from within Safari into my terminal, I get that prompt and the command is blocked altogether. So very clever and very pretty cool for Apple to design this mechanism within the operating system. So to conclude, on developer machines, terminal's behavioral checks get skipped, but xprotect these content checks are still on, and so you're still covered against known malicious domains. On non-developer machines, both are enabled, and what these don't cover is payloads that are hosted on like legitimate services like GitHub, Dropbox, Vercel, and domains that might not be flagged by Safari Safe Browsing yet. So, and anything, of course, that runs outside of terminal. Calvin in his talk mentioned malware using, just after these protections were added, how some malware authors were using AppleScript URL schemes to find different ways to achieve code execution. So honestly, I will say kudos to Apple for adding these protections, these paste protection systems directly into the operating system. I think they will help prevent a lot of ClickFix attacks. But please, Apple, add paste events into endpoint security so that other security tools can build on these protections. That's everything, and thank you so much for listening.